I give you Alex Ziskin.
Thank you. Okay. Hi, Amsterdam. And hi, everybody that came from all over the world. We have people as far as New Zealand that came here. Have you noticed that everybody here is riding bikes? This is crazy. I've never seen so many bikes. This is, I'm more from Washington, D.C., and I had 2 bikes stolen over there. I wonder how people don't get their bikes stolen here. Maybe they do. They do. They probably do, yeah? Yeah. Does this look familiar? This is probably what you use to secure your bike to a bike chain, something like that, right? Well, all right, let's see. Let's see how well this holds up. Watch out, everybody. Oh, I have your bike. Not very secure, is it? All right. So that was pretty easy. So we're here to talk about security in applications, though, not bikes, and we'll get to that in a second. Who's here to learn how to completely secure your NativeScript applications? Okay. I'm sorry to disappoint you, because that's not going to happen. It's just impossible. Okay? So I'm going to save you some time and say you can go have some coffee now. Okay, maybe not. Just hold on a minute. I'm sorry to disappoint you, but there are a few things you can do. So my job here is to raise awareness about security in applications. And if you walk away here not with a normal developer brain, but with the security on your mind, then my message has been conveyed. So while making your NativeScript apps completely secure is not possible, we can do certain things to help out. So while the thief can go ahead and cut your lock pretty easily, you can add things. You can add things to make it more difficult. You can add a chain, you can add a camera, you can add some lights, right? But can they beat the camera? Of course they can. They can wear a mask, right? But what if they forget their mask at home? This is exactly where you win, because you're relying on them to give up and go to the next place. So you make it more difficult for them to attack your application system, and they can move on quicker. Because nothing is unbreakable, but if you make it hard, they will give up. So those are the only 2 options you're giving to the attacker. You can give it to them the easy way, or you can give it to them the hard way. Have you ever played paintball? Who here has played paintball? It's fun, right? What do we do in paintball? Do we go like this? Hey, I'm over here. No, you go like this, right? You go and make yourself as small as possible, because try hitting me from back there. You can't. Well, you can eventually, if I don't move. So my job is to be small as possible and move around like this. Try to avoid getting hit. You make your surface area, your attack surface area, as small as possible. So that's going to make your opponent work harder to hit you, and they'll try to hit somebody else. But eventually, you do get hit. So don't rely on being super secure and super comfortable. So that's the field of cybersecurity in a nutshell. It just describes what you're doing in a metaphor sort of way. You're making it as hard as possible for attackers to get to your protected assets. So making it difficult for the attacker to get to your assets is important, but the biggest threats to mobile security are not mitigated by us, by developers. So let me get to that in a minute, but first I want to talk about the biggest threats here, and this is don't lose your phone and don't get it stolen. Why is that bad? This will give your attacker root access to your device and free your data. Fly free data, go everywhere. So this is another one. Wi-Fi, free Wi-Fi. I do this all the time. Who does this? This is not good. Very bad. So let's say you connected to Starbucks in the past, right? Google Starbucks, Google Wi-Fi, Starbucks. Your phone remembers that you've connected to it and keeps it in your memory. And when you're not at Starbucks, your phone is constantly sending out messages everywhere saying, is Starbucks here? Is Starbucks here? Is Starbucks here? And one day somebody will respond saying, yes, here I am, I'm Starbucks, but you're not at Starbucks and you didn't know that your phone connected. That means somebody's posing to be Starbucks and they are taking your stuff. So go through your list and delete your unwanted networks. It's in your phones right now, your saved networks that you've been to. So those are the things that you should take care of, but specifically we're here to talk about what can developers do, right, to make things more secure in your application system. And your application system is your client devices and your backend APIs. That's the entire system. So there's a common set of security recommendations that you could implement, and I couldn't complete this talk without talking about this first. We're going to talk about something else more important a little bit later, but now I want to talk about the OWASP Mobile Top 10, and this is a list that everybody should be looking at. I mentioned this during the workshop yesterday to some of these folks here. Many of these threats can be mitigated in your NativeScript apps, but many have to do with the entire application system, which includes your backend, right? So an equally important part of your app is to secure that backend, the part that you're not deploying to a device. Who has been at a company that has been attacked? Anybody? Oh, wow, okay. That's rare, but it happens. In fact, CodePen right now is experiencing a DDoS attack. I don't know if anybody knows this, but they've been trying to fight it for the last week or two. It's pretty crazy. Who would attack CodePen? That's just mean. So as JavaScript developers, today we're facing a new threat, a threat that's not part of the OWASP Top 10, because this thing came about suddenly and it's just in the news nowadays. Who knows what this could be? What's this dangerous thing that we're fighting in the JavaScript ecosystem right now? Anybody? All right, well, here's the hint for you, right? So you might have guessed. If you install NPM packages, that's where devs go. Devs go here automatically, JS devs especially, to go and get their stuff. And sometimes we just trust these things automatically, just like your grandmother trusts newspapers. I do this. Who else does this? So when a package has relatively many downloads like this per week, look at that, almost 1.4 million. That's got to be a good package, right? That's got to be great. Everybody trusts it. So you install it and don't even think to check all the dependencies there. There's a dependency tree that's huge, and you don't know what is in there. You just trust it. So what if a dependency of a dependency of a dependency, then of this amazing package that you've just downloaded, gets bought by somebody with the bad intention to steal data, or even worse? So what they can do is wait for an opportune moment and then replace one of the dependencies, and then you don't notice and bad things happen. And your grandmother, she doesn't even realize that the freelance journalist that wrote the column she's reading had ethics problems, and then they got paid to publish bad content. She'll call you on the phone and say, look, Amsterdam canceled bike lanes. And you're like, okay, Grandma, thanks. Now, speaking of news, this is real. NPM has been a big story recently, right? About a malicious user that took over a popular package to steal Bitcoins. Have you heard of this? And guess what? This is that library that I just showed you. That is the same slide right there. So this is the package that you trust, that you gave it a thumbs up because it has so many cool followers and it's all over Twitter and it's helpful and it does some kind of streamy things that you don't know what it does, but it helps. Look, I just want to get my application done, right? So you just download this. So how did this happen? All right, let's take a look at how this could possibly happen. So I have a little demonstration for you. This is, I'm going to create a little NativeScript app. So I've created a simple little NativeScript app. It's a NativeScript core application using TypeScript, just using the hello world template. And I sped that part up a little bit. So let's go into that project folder there. And I'm going to open this up in my editor, which is Visual Studio Code. All right. Let's get that open. I'm also going to kick this off so it starts building in the background. There is my page XML. Everybody's familiar with this hello world template, right? All right. Everybody here is a NativeScript core developer or NativeScript Angular? Which one? NativeScript core? Angular? We got some Angular folks. Core? Yeah. Vue. Vue in the house. All right, so what are we doing here? Okay, there's our NativeScript application. It rebooted. Very cool. All right, so here's my tap button. I'm tapping on it, and it has the 39 taps left. Very cool. But what I want to do really is, at the bottom, I want a nice little snack bar to appear. It's an Android type of UI device, and it looks kind of like that. So I Google for that, and that's what I want to appear there. And I do some more research. I find out, how it should operate according to the Material UI specs, and there it is at the bottom there. Here's some demos of it: top center, top right, bottom center, bottom left. Very cool. All right, so then I go to the NativeScript marketplace to see if there's something available, and sure enough, Brad Martin wrote a snack bar plugin for NativeScript, and it's available for iOS and Android. So that's the one I want to use. Let's go ahead and use that. It looks pretty cool. It's got the installation instructions, pretty simple. We have the usage instructions. There's our import. There's how to use it. I want to use that show simple one, so it just shows up a little message at the bottom of the screen. So let's do that. Let's install the snack bar. I'm getting to something, by the way. It's security related. So we're going to install the NativeScript snack bar plugin in our application. Very cool. All right. Oh, some people are having an issue with what I wrote up there. Okay, don't worry about that. We'll come back to that.
The spelling of NativeScript.
Thanks, Shiva. Good catch, by the way. So I'm going to go into my main view model, and I'm going to import snack bar here. And there it is, coming from that package. And I'm going to instantiate the snack bar in my main view model. New snack bar. Very cool. All right, and now where I update my message, I want to use the snack bar, and I want to show a simple message there, a simple pop-up. So I'm going to use that same exact message with a counter and how many taps I have left, and I'm going to put that in that message. All right, let's give this a shot. My app restarts, and there it is at the bottom. Yay! All right, I'm going to tap it. All right, it's working. Check it out. Very nice. Okay, so my snack bar works, and I'm very happy with this. And now I'm developing my application further. And let's say I want to add an HTTP call, a fetch, using the fetch API. It's a global API, right? Fetch is available globally in your NativeScript applications. So I'm going to create a new button here, and I'm going to call fetch data. And I'm going to call the handler on fetch data, on fetch tap. So we're going to use the fetch API here. And anybody use HTTP bin? It's a very cool, very cool little HTTP utility. It just gives you endpoints on the web, so you don't have to write your own backend. You just call a get or a post or an authentication, and you can just send it and it'll respond to you automatically. So I'm going to do a post request to http:/bin.org/post, and I'm going to include, my authorization headers because I want to fetch my personal data that's behind my protected API because I need an access token for that, right? So I'm going to need to use some kind of token. I just generated one here on jwt.io just to simulate a token. So there's my token. Of course, you're not going to store it in code like that. You're going to have it somewhere securely stored. And I'm going to add some body to the message as well. And then this returns a promise. So I'm going to use, I'm going to parse that promise, and then I'm going to just console out the data that comes back from the response, which is just going to send that back to you, what you sent over there. All right, pretty simple. Our app is executing a fetch request, and there it is. It's coming back on the console. So all the stuff you've sent is coming back. All right, so very cool. You know what? I knew Alex told me I should go check to make sure packages are safe. So I'm going to go and take a look at this NativeScript snack bar package and make sure that the packages that it's using, the dependency tree, are good to go and they're safe, right? So let's take a look at what it's using. It's using something called doCoolThing as a dependency, and it's got all these other dependencies. Okay, I'm not familiar with this doCoolThing. What is that? Let's take a look at that. So I'm gonna take a look at that in my npm modules folder, and there it is. Okay, let's take a look at what it's doing here, package.json. All right, so it doesn't have any dependencies, so that's good. It means it's the end of the line, it's a leaf. And what is it really doing here? Index, it looks pretty innocuous here. Say hi. Okay, it's got a little alert message there. Not a problem, fine, pretty safe. All right, so my application is done. I've deployed this to production. Very cool. In the meantime, maybe a month, maybe a year, sometime later, a bad person comes along and updates doCoolThing. Maybe they acquired it, maybe they owned it in the first place, and they replace the global fetch function with their own fetch function, calling this weird URL, right, with their own post request. And in the meantime, they're just returning to you the fetch that you've requested. But in the background, they're making their own call through this doCoolThing. So they go ahead and update the version. They don't even push this to GitHub. So if you check the GitHub repo, you don't even see this new code. You see the old code that just says hello or alert hi. And they push this new one up to NPM. Okay, we got a new version, and let's say that later on you get a new developer, and the new developer gets your latest code from your repository for your application. So we're simulating that by removing platforms and no modules here from your application. And let's say they start fresh with a new, fresh code base. So they're going to run TNS run iOS, so they're going to build your iOS application or your Android application, your NativeScript application. They're going to build it, and it's going to build fine, and it's even going to work fine. Everything's going to be fine. Your fetch call works, your tap, your snack bar work. There is your response coming back. Very nice. But what you don't know is that weird URL that we saw in the code, it's a bad guy. A bad guy just got your request. Check it out. They got your post request. You can take a look at it. There is your parameter, there's your token, and there's your super secret data in the body. Ooh, okay. Let's do that again. There's the fetch data again. Do we get new data? Yes, we do. Let's do it a few more times. And every time you make a fetch request, the bad guy's collecting your information. So, hopefully this brings a little bit more realism and awareness to what's happening behind the scenes. And can you do something about this? Maybe you can. You can use tools like Snyk. Anybody heard of Snyk? Yeah? SNYK. This is a tool that basically automated collection of vulnerable repositories on NPM. And NPM audit also is a good tool to use. You can use that one as well. So keep an eye out, make sure you check your stuff, trace your network requests, and next time you're writing code or doing a code review, just be mindful and have your security brain on. Thank you.